Hi guys, what I wanted to do with this video is I wanted to provide you hopefully with more guidance and to answer your questions on the Kinetics lab and your post lab that you are turning in at the beginning of class on Tuesday. What I wanted to do with this is just kind of walk you through what I'm expecting that you have in your lab and hopefully to answer questions on what you need and what you don't need. So first of all, with this lab, I would make sure that you first look at the rubric. So with this rubric, it tells you everything that you need. Formatting is going to be everything that you normally have except for this part that says each table is titled, labeled, and created using a straight edge. So what you need to do is every single data table needs to be titled and labeled. So what that might mean is data table 1, absorbance versus time. Maybe it says data table 2, part 2, absorbance versus time. Make sure that it's titled specifically, it's labeled with a number. So if you have 10 data tables, you should have data table 1 through data table 10. And then the reason it says created using a straight edge is because since you have so many data tables, you want to make sure that it's created using a ruler or a straight edge to make your lab look neater. If you don't use a straight edge and you just draw it free-handed, the lines are usually a little curvy and it's a lot harder to follow and a lot harder to read. So make sure that you follow that formatting tip as you work through. And then for the pre-lab, again, you should have that purpose procedure. We talked about that in class. And then when it comes to data and observations, I gave you everything that you needed for data and observations in this for both part 1 and part 2. So for part 1, you need your data table. Remember I told you in class you don't need all 200 points. I said pick about 10. To a lot of groups I told them to start at 0 and go up to 200 and just go by 25s, which is fine. But you need you need one big data table, or some people would want to do 3 smaller ones. It's probably easier just to do one big one. But you need time, absorbance, and the natural log of absorbance and 1 over absorbance. And then it says each column is labeled with units. Well, absorbance doesn't have units, so really you just want your units for time. So that's going to be your first data table. So going back to the formatting, for example, you can say data table 1 as the label, and then the title might be part 1, absorbance versus time data. That's fine as well. And then also for part 1, you want 3 graphs. You want your absorbance versus time, your ln versus time, and your 1 over versus time. And when you make your graphs, make sure that each one has a proper title. So make sure that it's labeled absorbance versus time, natural log versus time at the top. And then your axes need to be labeled as well. So your x is always time, and then your y is going to vary based on what you're focusing on. That all is under part 1. So what you need to have in your lab notebook is it needs to say part 1, or data and observations, part 1, put your data table, put your graphs. Then underneath you'll say part 2. Make sure I can find where that split is. Normally you want to make sure you have data and observations and it's underlined, makes it easier to find. And then maybe part 1, you can also underline that or box that or whatever you want to do. Just make sure I can find it. So for part 2, data and observations, you need one data table that is trial, temperature, and rate constant, because you're finding rate constant in your calculations. And then you need the absorbance versus time data for each temperature. So you did 3 temperatures, that means that you need 3 more data tables. So for example, data table 2, trial temperature and rate constant, data table 3, absorbance versus time at 40 degrees Celsius, data table 4, absorbance versus time at 30 degrees Celsius, and so on. And then you need qualitative observation. So what did the crystal violet look like when you put it in? What did it look like when you pulled it out? That kind of thing. Don't forget to include those qualitative observations. Then you have data analysis and calculations. That's all one section. So when it comes to data analysis and calculations, if we look at that section in the lab, you have questions specific to part 1 and questions specific to part 2. I think that the first question everybody pretty much answered based on what the order was. Keep in mind whatever the order of the reaction was at the beginning, that's going to be the order throughout. Question 2, calculate the rate constant K using the slope for your linear curve. Be sure to include correct units. And then with number 2, make sure you show your work for that. So if you use the y2 minus y1 over x2 minus x1, make sure you show that and I know what points you're using. And then number 3, write the correct rate law in terms of crystal violet. You can do that. Number 4, using the data table, estimate the half-life of the reaction. It tells you how to find the half-life. Just think about what that means, right? Find from initial and then the time it takes for you to have half of that. And then 5 says what would happen if the temperature were increased, so that's just a conceptual question. So in terms of number 1, the biggest thing that you're going to be showing me is how you calculated the rate constant. Make sure that you include units. Again, that is all. Data analysis and calculations is all one section in your lab notebook. When it comes to part 2, questions 6 and 7, this is where you're going to have a lot more work that you're going to be showing. The question 6 talks about the Arrhenius equation, and then it tells you based on your reaction order, along with your absorbance and time, find the rate constant at each temperature. This is where that data table, this is how you're getting the rate constant for that data table. And then it says to just show a sample calculation for the first temperature. So think about how you found the rate constant in number 2. You're going to be doing essentially the same thing in number 6, but you're doing it for the other 3 temperatures. So find your K based on your order. You might need to find the natural log of absorbance or 1 over absorbance, but you want to make sure that you find K correctly. So that might mean that you need to, again, natural log of absorbance, 1 over absorbance. Make sure you use the correct Y versus time. And then 7 says plot a graph of the natural log of K versus 1 over temperature, and then determine the activation energy. So I need to actually be able to see your graph in this because that's part of the question. It doesn't need to be very detailed. It can be a rough sketch. You can do it in your calculator, so you can actually plot what the graph looks like, but make sure that you give me what the intercept is or somewhere around the intercept and show me what it looks like, and then determine the activation energy. So think about why you need that graph in order to find the activation energy. So looking at the rubric, again, it says all calculations are shown and labeled. Each question is answered using complete sentences, and your graphs are labeled. So make sure you follow through this for data analysis and calculations. And then finally, you have your conclusion, and your conclusion just is it's the purpose, was it fulfilled, how was it fulfilled, but I also want sources of error. So give me at least one source of error and how it might have affected your results. If you don't think you had much error, I want you to give me what a possibility would be for sources of error based on this lab. If you find that you have any other questions, you can send me an email while you work on it, or you can come in before school to ask any questions. But again, I wouldn't waste too much time getting started on this, and just work on a little bit as you go just to make it easier for you.